So the goal, what we are trying to see, what are the different things that we can do in an on-call journey through AI that can significantly improve your productivity. That's the goal of this. So we are specifically going to talk in the context of a product called Jira Service Management. How many of you used either Ops Genie or Jira Service Management? Okay, that's a lot of you. So Jira Service Management, originally we had two products. Now we are actually moving all the capability of Ops Genie into Jira Service Management. Jira Service Management has a lot of functionalities. I'll give you a quick context of what we're going to talk. There's a pillar of features that we call as IT operations, which takes care of alert, on-call, incident management, change management, problem statement, everything to do with what an on-call engineer will go through. That's pretty much what we are going to go through in this one. So whenever you are in an on-call journey, there are three things that you actually worry for. The first one is detect. Detect is, can you detect the problem well in advance? Not after the problem occurred and the customer calling and telling you, right? This is like, can it do a little more earlier? The key metric that we measure in most of the places is time to detect, TTD that we call. Here we'll see what are the different things we can do to improve our TTD. The second one is resolve. Okay, now we have identified the problem. There is a problem. Can we identify the root cause? I think this is where a significant amount of capacity is spent by the on-call developer. And in resolve, there are two things. There is a mitigation part of it, which you do temporarily to bring back the system. The other one is, can you resolve a permanent solution to do it? Here we'll walk you through a lot of things that Jira Service Management can do, which helps you in this one. The last is prevent, to proactively mitigate incidents. For this topic specifically, this talk, we will focus only on detect and resolve. Okay, so let's take Pete as an on-call engineer, right? One of the good things about being an on-call is, actually I had a lot of positive things, not so great things also. The positive one is, actually I learned the system very fast when I was a developer through on-call. The next important thing is it taught amazing debugging skills. For most of you, it would have been the same. But the not so great part is sometimes your work-life balance can get really messed up. That's one of the problems on the side. So now let's say Pete is actually in a weekend having lunch with the friends. You can see situations like this. Every on-call person would have felt, right? When you're outside having your own life, that time suddenly your alerts keeps flooding over, like hundreds of them keeps coming in, right? This is very normal. When you get hundreds of alerts, what's the first thing that comes to your mind? Mostly the entire system is gone, right? Pretty much everything is broken. There is nothing which is running in. Mostly my weekend is screwed up. That's the first thing which comes to mind. If you're an on-call person, let's say you're having lunch outside, what's the first thing you will do? Okay, let me start checking one by one alert right there, okay? Maybe you'll see 3-4 alerts, and the first thing you will conclude is, hey, mostly all of them, the first 4 alerts look same. Mostly all of them are same alerts. Okay, it's one particular problem which is there. And you will stop it over there. It might be right, but it need not be also. It is also possible the 70th alert and the 90th alert can be a completely different problem. And if you didn't detect that one, what will happen? You would have missed the TTD. So when you miss the TTD, the primary problem is your resolve will take more time because resolve includes TTD, right? So every company has a strict SLA on which we do. How can Jira Service Management help you in this particular journey? This is a huge one. I don't know if you can see it. So all of these features are in production. So I'm just watching the production screen is what I'm going to show you. If you see here, when you get hundreds of alerts, it pretty much groups you into 4 alerts. It says there are actually only 4 problems, but it just so happens the first alert grouping, you see that 127 alerts, that what Pete got of 127 alerts are actually for one particular problem. The second alert points to only one particular problem statement. But now this is very interesting problem to identify, right? It's not very simple. Why? The alert which is coming in can come from a service which you own, or it can come from another service which your org owns but not your team. Or the last one is, it can actually thrown by some downstream platform organization which doesn't even come under your org, right? But you have to detect if all of these are actually pointing to one particular problem. So there's a lot of logic runs behind here to bring us that capability of alert grouping. And think about if Pete is sitting outside for lunch, and instead of getting hundreds of alerts, you get exactly 4, and say there are 4 problems. Productivity, lot of productivity saved, right? Otherwise, you literally should have gone into all of these alerts one by one to hash it. That's the first one. The second one is now you have identified the group, you click into the group. And even though AI would have done a great job, most developers, hey, give me a place where I also eyeball. That's a screen that we show in, where you can eyeball a group and figure it out, is everything grouped correctly. The next one is, hey, now you've got so many alerts, right? But the first thing is, you're a seasoned engineer, so you know, looking at the alert, you can exactly tell what is the problem. Or you're a brand new engineer in the team who is like, hey, I am not sure what's exactly the problem, even though I understood these are all pointing to one. Based on the historic trends of alerts, it will actually give you a very clear description of what is the exact problem statement. And that's what comes over here. Now, the next thing is, you decided, okay, there is a problem. Now I want to create an incident, correct? So most developers, when they create an incident, what do? You have to really go ahead and capture all the details in the incident ticket, right? That spends a significant amount of time to get all the context. But what will here do, the AI will help you based on all the patterns of the alert and the historic incidents that would have been created. It will actually create you an incident with full data, fully populated immediately the moment you say create an incident. And you can see this one right there. Now the incident is created. The next most important thing is, okay, tell me where the problem is, right? That's where we spend a lot of time identifying the problem. This is where the complexity or the full power of AI that we bring in to say, if you would have seen this pattern before, or based on the service graph that we have in, and a lot of other attributes, system will be able to identify a few set of services, possibly it can be there. And it will give you, hey, highly likely this is a service which is a problematic one. And here in this example, it will say, hey, there is a very high chance it is actually failing because of a payment service. Now, the next thing what you will do is, okay, I found out there is a problem in payment service, but that payment service, we don't own. It is actually owned by somebody very downstream, assume in a platform organization. But I know that is problem there, but how do I know what are all the upstream services which are getting affected? Now, you are a developer and on call. If you have to identify the full service graph, it might take quite a long time for you to run, because it's not easy that every system is running on the same APM for you to run the call trace also. Because the platform organization can have a different APM for you, you might have a different APM for you. So you will need one particular place where all the observability data comes in to give you the full service graph to say, hey, if the payment service is down, these are all the upstream services which can actually take an impact, and can we pinpoint where the problem is? And now you will know what is the impact out of this one. Now, you know where the problem is, and you know it belongs to some other organization. What's the next thing you will do? Actually, you need to page somebody, right, in the dog. Have you folks felt this one? We know which team it is problem, but we don't know whom to page. Have you found out this problem? All the time we'll keep on pinging, hey, who's the right person? And believe me, this actually spends a lot of time when the organization is very big. Now, what this will recommend you, Jira Service Management, is based on the historic incidents and the alerts it has done, it will absolutely say in this example, hey, add Sarah Davis as a responder because she has handled this particular similar incident, and it will give you the similar incident also. Or add the next person who has handled these incidents which are of similar pattern in the past. It might be very old data. So this actually reduces a lot of time. So now you add Sarah Davis. Now the first thing is, okay, somebody else got paged because they belong to that system. They come on call. Have you seen first time when you're in a bridge call, an on-call engineer, you started the incident, and every new person that you page, when they join the call, you know what they'll ask? Hey, can somebody explain to me what the problem? Have you seen this? And there will be like 20 people keep on joining, and every person will ask the same thing. Can somebody give me actually what is going on? What's the problem? Sarah Davis got paged. The best part is, Sarah, when she came in, has a full description of, this is an alert you got, this is an incident, these are the related calls, these are the similar Slack channels which happened in, this is the affected service. Sarah has all the context. So somebody doesn't have to come back and say, okay, give me all the details. Sarah, since she has already worked on before, she automatically knows this is a big problem. So the first thing she does is mark this as a major incident, right? That's what it shows in that one. It is marked as a major incident. The one thing that happens is when you mark as a major incident, Jira Service Management runs an automation in the back which says, okay, I'm going to give you a Slack channel I'm going to create, and that's what it will do here. It will create a Slack channel, and it will do many things in this one automatically, the moment you mark it as a major. What it will do, it will give you a full description of the problem, the affected services, all the responders, and it also add all the people who are related to this one automatically into this one. So immediately you have a Slack channel which is fully running in. You might ask, why only Slack? We have other channels. Teams also it can do. So that's the first thing which will start in. So now you have a full-fledged capability of, now the Slack channel is ready, so you don't have to worry, you can actually start collaborating in this one. The next thing what you will do, now you identified the problem, there are two ways you can resolve. If you are a very deep tech company, so where you say, okay, based on every alert, we want to build a full-fledged automation capability. It can be a full-fledged DAG, which can automatically get triggered, and it can resolve the problem. It is possible. That's the first thing which we call as a full-fledged automation capability that we have, which you can trigger. But if you look at it realistically, most places, when you have a runbook, the runbook will have few scripts to execute automatically, but few steps to execute manual. That's what most of the time would have happened, right? Very rarely I've seen companies where an alert comes in, 100% automation runs, and if you're doing, it's awesome. So we will show you an example of, based on the incident, Jira Service Management will automatically recommend you, hey, this is the playbook you need to execute. And actually the playbook will give you step-by-step instructions of what you want to do. Here it will confirm, for example, hey, identified this is the service owner on it, you want to roll back it, bring it to the stable step. The idea here is, whenever you created a playbook, previously you would have created a playbook in a Confluence document or a Google Doc, which you need to manually go read and start executing one by one. Sometimes you don't even know which is the playbook. Nowadays people say, as part of the alert itself, they trigger the playbook link. But let's say the system can actually tell you, hey, this is the playbook, and this gives you a list of instructions already tracked inside. That's what the next thing runs in. So now you have ran the playbook, or you have either ran the automation, and you got the system to a stable state. It is mitigated. I think the next problem is quite an interesting problem. How many of you do post-incident report, PIR report, in your place? Right, okay, good chunk of you, because Atlassian has this process. And there is a good thing, and there's a very painful activity. The good thing is, there is a single place where we want to go and review everybody, what is the problem, what is the RCA, and is there a strategic fix on that done, right? But the not so great part is, the original alert person has to write everything manual. And it's a very painful activity. Why? In the PIR review, we usually tell, okay, what time it started the problem, what time you detected TTD, what time you got paged, what time you attended. Every nuances detail has to be collected together. It's a lot more painful activity, right? Now we have an AI agent which will actually generate the full-fledged PIR for you. What is the benefit of this one? If you look back, I have an incident, there's an incident ticket, there's a lot of Jira tickets associated to that, there's a Slack channel, and a lot of conversations happening in the Slack channel which you want to collate, because everything is in some form of all these documents, right? The system will capable to go collect from all these documents and automatically generate a full-fledged PIR report. Now you can actually go ahead and review this PIR report and decide whether you want to add more, edit more, or directly publish. The idea of all these things is, can it improve productivity at every step of the journey that we want to do in an on-call management? This is just a glimpse of it we want to show in, because we're not trying to go through every feature of JSM, just to get a glimpse of it. Now the next one, what you will do is, we want to walk you through a few things about what are the different, easier way to do automation, because automation is very complex. And this one, what we'll walk you through is, we'll give you a lot of templates for you. Hey, if this is an alert, what is a way you want to trigger an automation? Those are the templates which we'll walk you through in an automation journey. But the next most important thing is, if you're a manager, have you noticed every time there is an alert or an incident happening in, and every time people fix it, but you never got to know that there are similar pattern of incidents happening all the time, which you want to strategically fix. Sometimes you never got to know, right? So what this one will do is, hey, you see the create problem ticket here. There are two incidents over there, which is similarly happening in, and in the same service, do you want to have a strategic fix? The system will say that every time that you are seeing this problem continuing to happen, it will prompt you to say, hey, I think you need a cleaner fix. Can I create a ticket for you so that you can start tracking automatically? And that's the purpose of a problem ticket that we recommend on this one. That comes pretty much the end of the journey of what we are doing it. But the idea is to say, hey, there are a lot of AI capabilities that we bring in for an on-call engineer productivity to improve. That's pretty much it. Happy to see you folks. Thank you.